the topic of discussion that we are going to deal right now is we're going to talk about what? We're going to talk about thalamus. So in this topic, what we'll be discussing, we'll be talking about thalamus, its different components, it's the nucleus present within it, and then what we'll do, we'll just learn about the different connection that it has, right? So the focus of discussion will be the structural study and the nuclei and their connection of thalamus. So without delay, let's begin our discussion. Now talking about thalamus, right? What is thalamus? Thalamus is what? It is a sensory gateway that sends sensory signal, right, to our what? To our cortex. If you remember, thalamus was what? Thalamus was a structure that was sending what? It was sending what? Our that corona radiations to our what? To our cortex region, right? To our cortex region, or we can say thalamus as a point of relay, right? Okay, so every sensory impulses travel through thalamus, except one that is what? Olfactory, right? Olfactory sensation don't come to thalamus, right? Okay, so this was what? This was our thalamus. Now talking about thalamus and its position. What is thalamus? It is a ovoid large piece of gray matter. It is a ovoid large piece of gray matter, right, just above our what? Just above brainstem, or you can say just above our what? Midbrain, right? Midbrain. Now midbrain is separated from what? Our this thalamus with thin tissue called what? Subthalamus. So that is what? That is the position of thalamus. Now talking about its part, right? Talking about its parts, it is what? It is ovoid in shape, and it is divided into how many parts? 3 parts. What are the 3 parts? These are the 3 parts: first part, second part, and third part. Okay, well, dividing into 3 parts, it is divided by Y-shaped structure, right? It is divided by Y-shaped structure, and this Y-shaped structure is what? It is white matter, Y-shaped white matter structure, and this structure is called what? Internal medullary lamina. What it is called? It is called internal medullary lamina. Okay, this internal medullary lamina, what it does is it will divide our this thalamus into what? Into anterior part, into medial part, and into what? Into lateral part. Anterior, medial, and lateral part. Okay, this is what? This is a brief introduction. Now we'll get into what? We'll get into its nucleus after looking the position of thalamus. Okay, if you remember, what is this? It is our corpus callosum, right? Here you can see what? Lateral ventricles. You can see lateral ventricles, and then in this side, what we'll find is we'll find caudate nucleus, right? Caudate nucleus, and here in this, what we'll find? We'll find thalamus. Now just lateral to them we'll find internal capsule, and then lateral to them we'll find what? We'll find what? Nucleus, right? Lentiform nucleus. Okay, so the position of thalamus is right here. Position of thalamus is right here. Just below thalamus we have got what? The thin tissue. What was that? That was our subthalamus. And if you will see medially, what we'll find medially? The roof of third ventricle. And the roof of third ventricle is made by what? The roof of third ventricle is made by our choroid plexus, right? Choroid plexus. Okay, now if you will see clearly about thalamus, then this thalamus here, the axis of thalamus is going what? Going posterior laterally. It is going posterior laterally, right? Now if you will just, it moves what? It moves anterior, right? Anterior, right, and posteriorly. And talking about anterior goes what? It goes medially, and posterior it goes what? It goes laterally, right? So the anterior end, right, that goes medially is close to what? This structure. What is this? This is our interventricular foramen. Okay. Now yes, this is the position of our thalamus. Now moving further, the same structure, that means the parts. Okay, we already said that there is a structure. What is that? That is our internal medullary lamina, right? Internal medullary lamina will divide our this thalamus into what? Anterior part, right? The medial part and the lateral part, right? This whole lateral part. Okay, now these parts consist of different type of nuclei based on their position. Okay, now what were the 3 parts? The 3 parts were our anterior. What were the 3 parts? These were our anterior, right? And then our what? Anterior, then medial, right? Medial, and then our what? What was the another part? Lateral, right? Lateral. Now these consist of different type of what? Different type of nucleus. For anterior part, it is simple that it consists of anterior nucleus, right? Anterior nucleus. Talking about medial part, this medial part also consists of 2 type of nucleus. The one that can be seen from above, that is dorsal nucleus, and the one that is not seen from above or can be seen from below, that is ventral what? Nucleus. So the medial part consists of what? 1 dorsal and 1 what? 1 ventral. Now talking about lateral. Now right. Now talking about this lateral one. This lateral one is further divided into two part. As you can see, it can be further divided into two part, right? Two part. Now the two part are, these are what? These are the dorsal one, right? These are the dorsal that can be seen from above, and the below one, these are what? These are the ventral one that cannot be viewed from above. So these dorsal part, right? Dorsal part are also divided into what? Different types, right? This dorsal part also consists of what? Different type of nucleus, such as the first one that I am writing right here, it is what? It is lateral dorsal, right? Lateral dorsal. And this one is lateral posterior. Okay, it is present backwards, so it is lateral posterior. And this, the large one, that is our what? Pulvinar, right? It is our pulvinar. So these are what? These are what? These are the nucleus that are present where? On lateral part, on lateral also, on lateral dorsal part. What are these? These are lateral dorsal, lateral posterior, and pulvinar, right? So these are found where? These are found on dorsal tire nucleus, right? These are what? These are found on dorsal part, that is, these are called dorsal tire nucleus. Now similarly, talking about this ventral part of lateral part of what? Our thalamus. These consist of what? Ventro-anterior, ventro-lateral, and ventro-posterior. Ventro-posterior consists of again the two type of nucleus. These are ventro-posterior lateral and ventro-posterior medial. If you remember, ventro-posterior lateral, this is the point of relay for what? For the sensation coming from lower and then mouth region of our body. And ventro-posterior, right? Ventro-posterior medial, it is the relay station for the sensation coming mouth and above mouth region. So these are what? These are the nucleus found on what? The ventral part, right? Ventral part of lateral part of what? Thalamus. So these are called ventral tire nucleus, right? Tire nucleus. So these are what? These are different type of what? Nucleus. Now what we need to know is the connection of thalamic nuclei, right? We need to know the connection of thalamic nuclei. Now while talking about the connection of thalamic nuclei, right, we are dividing, right, based on the connection, we are dividing these these nuclei, right, into two parts. The first one is our what? The first one is specific, right, specific nuclei, and the second one is our non-specific, right, non-specific nuclei. Now what are these specific? Okay, these are called specific nuclei because they receive afferent from what? The ascending pathway, right? Ascending track, and non-specific are the one they will receive what? Afferent from other than ascending track, right? From other region than ascending track, like diencephalon or like that, right? Afferent from other diencephalic nucleus. So now talking about specific nuclei, the specific nuclei consist of what? It consists of, specific nuclei includes what? It includes, right, all the nuclei, right, all the nuclei on ventral, right, ventral part of lateral what? Lateral thalamic nuclei. If you remember the ventral part, that means here we are talking about this region, right? These are included into what? Specific nuclei. That means they will receive what? Their what? Afferent from our what? Ascending ascending tracks, right? Along with this ventral part, other two also. Other two, what are the other two? These are present right here, the lateral geniculate body and medial geniculate body. These also receive what? These also receive afferent from our what? Ascending tract. So these are considered as specific nuclei. So they are so important to know, right? They are so important to know, and we need to keep in our mind. And what are these? These are ventral anterior, right, ventrolateral, and ventroposterior. Ventroposterior what? Ventroposterior lateral and ventroposterior medial. So these are what? These are our what? Specific nuclei, and other remaining every other are our what? And also from what? Also our lateral geniculate body and medial geniculate body. These are what? These are our what? These are our specific nuclei, and remaining are non-specific nuclei. So here there is a mentioning of same thing again, right? This is the ventral part. What are the ventral part? Right, the ventral part, our what? The ventral part nuclei. What are the ventral part nuclei? These are ventro-anterior, ventro-lateral, ventro-posterior, right? Along with these the lateral geniculate body and medial geniculate body, these are the part of what? Specific thalamic nuclei, right? And remaining other all like anterior nuclei, right? We have what? We have medial dorsal nuclei, right? Medial dorsal nuclei, medial what? Medial ventral nuclei, right? And here what we have here? We have lateral dorsal, lateral posterior, and fulvinar. All these are included into our non-specific. So now initially we'll be talking about the connection of specific nuclei. As I have already mentioned, what are these? These are our specific nuclei like ventro-anterior, right, ventrolateral and ventro-posterior. So ventro-posterior also divided into ventro-posterior lateral and ventro-posterior medial, right. Now from where they receive the efferent? They receive efferent from different part, as you can see, right. They have a specific location that they are receiving efferent, and then what they will do, they will send their efferent to a specific part of the cerebral cortex, right. As you can see, what is this? This is our brain, right. Our brain here. What is this? This at the center. What is this? This is what is this? This is our central gyrus, right. Central gyrus. Now front of this central gyrus, what is this? This is our pre-central gyrus, right. It corresponds to Brodmann number 4. And back of our this central gyrus, what we have? We have post-central gyrus that correspond to Brodmann number 312, right. And front of our pre-central gyrus, we have premotor cortex. Now this premotor cortex correspond to Brodmann number 6. So we know about it, right. Again I am repeating, this is our central gyrus. Front of central gyrus we have we have pre-central gyrus, Brodmann number 4. Back of our central gyrus we have 312, Brodmann number 312, that is post-central gyrus. And front of our this pre-central gyrus we have we have premotor cortex that correspond to Brodmann number 6. So now let's begin here. So here if we will talk about ventro-anterior nucleus, right. Ventro-anterior nucleus, it will receive it will receive efferent from our this globus pallidum. Now globus pallidum, if you remember, what is this? This is our putamen nucleus, right. But our this ventro-anterior nucleus, it will receive efferent from globus pallidum only, right. And after receiving efferent from here, it will send efferent to our cerebral cortex, and where? In our this premotor cortex, that is Brodmann number 6. Similarly ventrolateral, right, ventrolateral nucleus, it will receive it will receive efferent from our dentate nucleus. If you remember dentate nucleus, where we studied this dentate nucleus? We studied this dentate nucleus where? Just before this lecture. In which region? In our this cerebellum, right. In cerebellum there were there were different deep cerebral nuclei. They were dentate nucleus, right, dentate nucleus. So they receive efferent from where? They receive efferent from dentate nucleus. Now from this dentate nucleus, now some of them directly go to ventrolateral nucleus, but some of them they connect with red nucleus, right. They connect with red nucleus, then they go to they go to this thalamus and then to cerebral cortex, right. And they go to Brodmann number 4, right, pre-central gyrus. Okay, now this pathway, what is this pathway called? Dentatorubral dentatorubral thalamic path, right. Dentatorubral thalamic path, right, because from dentate to red nucleus to to our thalamus, right. Okay, now talking about VPL, right. VPL, now that means ventral posterior lateral, right. Ventro posterior lateral nucleus and ventro posterior medial nucleus. So what they do, let's talk about VPM initially. Ventro posterior medial, what they do, they get efferent from they get efferent from our head and neck region, right, head and face region, let's say. Now from head and face region, where they get efferent from? Exactly, they get efferent from trigeminal lemniscus and solitary nucleus, right. After getting efferent from this region, they will send it to the Brodmann number 312, right, post central gyrus, right, for processing. Now similarly our ventro posterior lateral nucleus, what it will do, it will receive the efferent, right, efferent from our medial and spinal lemniscus, right, medial and spinal lemniscus. And then what they will do, and then they will they will just send it to the same position, the Brodmann number 312, post central gyrus. So this was about this was about our specific our specific thalamic nuclei, right, about their about their efferent and about their efferent, right. Okay, the same thing is mentioned right here, VPM, right. If you remember VPM, they get efferent from where? They get efferent from our trigeminal lemniscus and solitary nucleus, and then efferent goes to 312. So the same thing is present right here, but the one thing that I would like to mention here is medial genucleate body and lateral genucleate body. Medial genucleate body is responsible for what? Auditory. That means they will carry the efferent fiber for medial genucleate body is auditory fibers, right? Similarly, lateral genucleate body, visual fibers. So we know the what auditory, right, center is Brodmann number 41 and 42. Similarly, for visual, right, it is Brodmann number 17. Okay, so these are about what? These are about specific thalamic nuclei. Now talking about non-specific thalamic nuclei, right, let's talk about what non-specific thalamic nuclei. Now for that we need what? We need two diagram, one showing the medial aspect, right, a brain's medial aspect, and another showing what? Another showing completely what? Superior aspect, so that we can see superiorly. So we know that except this one, other all, right, anterior nucleus, right, medial nucleus, lateral what? Dorsal, lateral posterior nucleus, right, these everything falls under what? Non-specific nucleus. Now what are their efferent and what are their efferent? So okay, let's begin with our what? Our anterior nucleus. Now these anterior nucleus, they will receive what? They will receive our they will receive what? They will receive efferent from what? Our this mammillary body. As they will receive efferent from mammillary body, what they will do? They will send what? They will send our these efferent, right? They will send efferent to our cingulate gyrus, right? They will send efferent to cingulate gyrus. Now moving further, what we have? We have lateral dorsal nucleus. Now talking about lateral dorsal nucleus, what they will do? They will receive what? They will receive efferent from our these ventral tire nucleus only, right? These lateral dorsal, lateral posterior, right, and our this pulvinar, all these which are what? Which are the dorsal tire nuclei, they will receive what? They will receive efferent from where? They will receive efferent from just below them. What are below them? These are ventral tire nuclei. So ventral tire nuclei will provide efferent to these structures. Now after getting efferent from these structure, what they will do is they will just send it to their destination. For example, our this lateral dorsal nuclei, it will send efferent to our cingulate gyrus, right? Similarly, talking about lateral posterior nuclei, what it will do? It will send what? It will send efferent to our superior parietal lobule, right, present just above what? Our parietal lobe, right? Similarly, now talking about another pulvinar, what pulvinar will do? It will send what? It will send efferent to different associated area, like the area of what? Occipital area for here hearing, like that. And talking about what? Talking about our median nucleus, what it will do? It will what? It will this median nucleus will send what? Our this efferent to prefrontal gyrus, right? Will send efferent to prefrontal gyrus. So now the same thing is written right here. That means nuclei, anterior nuclei, right, what? Efferent from what? Our this mammillary body, efferent to cingulate gyrus, right? And the function, since the what? Since and they have what? They have different functions. The function is needed to mention right here. So the anterior nucleus, right, it is what? The function is for what? Recent memory and attention. That means it is performing RAM like function, right? Okay, now talking about what? Our this median nucleus, right? The efferent is from where? The efferent to medial nucleus is from thalamus and hypothalamus, and the efferent goes where? The efferent goes to our prefrontal area, and it is what? The function of our the medial nucleus is it regulates our mood and emotional balance. Similarly, what we have? Lateral denticulate nucleus, its and lateral posterior nucleus and pulvinar, all these have what? Same efferent. These are ventral tire nucleus, and then this lateral what? Lateral dorsal nucleus will send the efferent fiber to cingulate gyrus. Similarly, lateral posterior nucleus will send it to superior parietal lobe, and pulvinar will send it to associated area. And they have the maximum of them have the function of integration, right? But the pulvinar, right, it correlate auditory and visual information with other areas. So these are the what? The function and connection of non-specific thalamic nuclei. So this much for the topic. I hope we are clear with this topic. Thank you and have a great day.